The objective is going to be to download a huge database of handwritten digit images where people have written digits like 0, 1, 2, 3, and so on, and then train a multi-layered neural network to identify which digit an image is showing us. So we'll be using a database called MNIST to do this. This has about 60,000 images of handwritten digits which were written by nearly 500 different writers. All these 60,000 digit images also come with the labels, the correct answer for which digit it is. Once we train a neural network using these images, the idea is that given a new image, the network should be able to classify it as the right digit between 0 to 9. The first step is to download this database of images from the MNIST website. This is maintained by a famous neural networks researcher called Jan LeCun. So we'll go to Jan LeCun's website and download this MNIST database of images. The second step is to set up a neural network with a number of layers. We'll have to specify what the layers should be, how many nodes there will be in each layer, and also how the network will have to train itself. What should be the algorithm it will use to find the right weights to represent the network. Then as step 3, we'll actually feed in the entire training data to the neural network that we've set up, and it will go through a training step and find the weights that represent the network. Then we'll check how the output is for one image. We'll feed one image to this trained network and check what the output that it's giving us is. And the last step, we'll actually feed a test data set of about 10,000 images which already have labels. This also we'll get from Jan LeCun's website, and we'll feed this to our trained neural network and see what the accuracy of the network is on these new images. We'll start by writing a simple function that will download the MNIST image files from Jan LeCun's website and then extract the images from the zip files and also the labels from the zip files. So if you go and search for MNIST, the first link that you get is the MNIST database website, and on that page you will see that there are 4 files which are available. One which has the training images, these will be about 60,000, then the labels for those training images, then another 10,000 test images and the labels for those test images. So the idea is that we'll write a function called load dataset that's going to download these files, unzip them, get the data out, and give us the training test data both as numpy arrays. So first we'll define a download function that, given any file name, can go to the Jan LeCun website and download that particular file. This is straightforward. We're just going to use urllib, which is a standard Python library for downloading stuff, and use the URL retrieve function from there to download the file name that is specified. Here, that particular function will just download the file and store it onto our local disk. So this function we'll call later on when we are trying to load the data for the images and the labels. Now the zip file for the images is slightly different from the zip file for the labels. So we'll define 2 functions. One which unzips the zip file for the images and the other which unzips the zip file for the labels. So load MNIST images is the function that we're writing that will take a file name. First it will check if that file is available on our disk. If it's available on our disk, then it will continue further. If it doesn't exist on the disk, then it will download it from the website. So we've forgotten to write all our import statements here. We're using the OS module here. So the import OS statement I've not shown you earlier. but make sure you write that before you run this program. Also, you'll have to import NumPy as well for the next step. So here we're extracting the contents of the zip file. We're opening it up using gzip.open, and we're opening it in binary mode because we know it's a zip file, which is a binary file. Then we're just going to read the data into a NumPy array. So data is a NumPy array, and we are going to use some boilerplate which reads this stream of data which comes from the file. It's a binary stream of data and feeds it into this NumPy array called data. Here we are specifying that the NumPy array has a data type of integer. So at the end of this line of code, what you have is the entire file of the MNIST image database has been read into one single one-dimensional array. So now we have two issues that we'll need to solve. The first is that the data can't be one single long array. It has to be an array which represents the images. So each element in the array should represent one image. The other problem is that the numbers in the array are in the form of bytes, and we want to convert them into floats. So that's a simpler problem. First, let's talk about the problem that is converting this long one-dimensional array into an array of images. So we'll have to take this array and convert it into images by reshaping it. Each image has 28 by 28 pixels. This is something that we know. Each image in the MNIST database, it's a monochrome image, and it is represented by 28 by 28 pixels. So the number of channels or colors that's required to represent each pixel is different for monochrome images and full color images. For monochrome images, you would have only one channel. The intensity or the number for that channel would represent the grayness of the pixel. For a full color image, you would have 3 or 4 channels, each would represent one primary color. So we're going to use the reshape function from NumPy to reshape this one long array into an array of images. So we're importing NumPy here because we forgot that before, and we'll go ahead and reshape the data array into an array of images. So there's a convention to reshape images. The convention is that you will have an array with 4 dimensions. The first dimension represents the number of images there are. The second dimension represents how many channels there are, and the third and fourth dimensions represent the pixels. So this is a little tricky. Let's talk through it once again. The first dimension we have used is -1. This just means that we don't know what the number there should be. You should infer it from the other dimensions and the total size of the array. So ideally there should be 60,000 images, but instead of risking that, we're just going to say that you should infer the number of images from the value of the other dimensions and the length of the input array. So since the length of the array or the size of total number of elements of the array are going to remain the same after reshaping, if you just give the other 3 dimensions and the input array, the number of images can be inferred. Then the second dimension is simply the number of channels. Here it's 1 because it's a monochrome image, and the third and fourth dimensions are the size of the image. We know that it's 28 by 28. Now we're converting the data from bytes into floats by just dividing by a standard float number from NumPy, and this will convert the byte value to a float in the range of 0 to 1. So what's happened here? At the end of this, we have the data represented as a 4-dimensional array. And each number represents the color value of a pixel in some image. So just like we unzip the images file, we'll also have to unzip the labels file. This will be much simpler. We're again first checking if the file exists already on the disk. If it exists already, we'll just move ahead. Otherwise, we'll download the file. There's an indent problem here which will throw an error, and I'll come back and fix it later. But the with statement should be indented just into the function and not as part of the if statement. So we're opening the file here using gzip.open and then just reading the data into an array like earlier. Now in this case, we just have an integer for each image. So the NumPy array of integers that we get by reading this file is exactly what we're looking for. Each value corresponds to the correct label for the corresponding image. We'll just return this array. So we'll return the data as the result of load MNIST labels. Now we'll call both of these functions to download those files that we saw on Jan LeCun's website. So we're setting up one variable for the training set of 60,000 images, and the labels of those 60,000 images will be stored in ytrain. Similarly, the images of the 10,000 test images will be stored in xtest, and the labels of those 10,000 test images will be stored in ytest. We'll return all four of these arrays as the result of the load dataset function. So the load dataset function will return the images and labels for the training data and the images and labels for the test data. Let's just call that function so we can get our data from the website. We'll see if there are any errors and debug them. So there seems to be one error. That's the indent error that I was mentioning. So we indented the with statement wrongly. Let's fix that. Let's see if there are any other errors. So there's one more error, which is the name of the file that we are trying to download. Let's fix that. And then the function works fine. So now we have four arrays, one with images, one with labels for the training set, one with images, one with labels for the test set. We could go ahead and look at one of the images in this training set. We can see what it looks like. To do that, you can use matplotlib. So we'll just import matplotlib and we'll set a default image rendering option. This may or may not be necessary. For me, it works only if I do this. If the default setting for you is set properly, then you may not need to run this particular line. Then you will just import a function called pyplot, and we'll use pyplot.show to show the image, pyplot.imshow to convert the xtrain1 array into an image. So the imshow function first converts the NumPy array into an image, and the show function shows that image. So xtrain of 1 is the second image in the training set, and that's a 0. Let's check what xtrain of 3 is. That will be the fourth image. That looks like this. It's a 1. Okay, cool. We've got our data all ready and set up to go. Now we actually have to set up a neural network and train that network on this data. And that's what we'll do in the next section.